So what we're trying to do right now is let me give a visual example here. So we have this game called Lights Out on the Tiger Gamecom. It looks like this. Hold on. I guess I could show it on screen. I have an emulator I can pull up, but whatever. You might even know what Lights Out is just by saying that. But yeah, it's this. Come on, load already. Anyway, it's a game where it's a puzzle game where you gotta like tap lights to turn them on or off or whatever. But yeah, it's like, you know, it looks like this, right? You can press button. I don't know what I'm hitting. Yeah, it switches whatever the surrounding tiles are, and the goal is to turn all the lights off. We're trying to beat that. However, problem with that is, I'm sure I can individually solve every puzzle, but emulation-wise, I can't. I have no save data because the only emulator that works with this game does not save state. So basically, every time I like stop playing it, I'm reset back to level 1, and there's like hundreds of puzzles in this, presumably. So instead, because I know how to code, what my plan is to beat this game, potentially on stream. I mean, I have, as you just saw, I have a physical version of this game and the console that it runs on, so I could just beat it off stream and be like, yeah, I beat it, whatever. But that's not that exciting. Instead, we're going to try to write a program that can optimally solve any puzzle given a 5x5 grid for Lights Out. One very important caveat to this is that particular port of the game will not allow you to progress if you use too many moves in your solution. So you can't just do like the any percent solution for solving it. You have to have not the optimal solution, because you can go a couple steps over. It'll tell you if you go over. But somewhere in the neighborhood of like a relatively optimized play. So that's our goal right now in the next like 20 minutes left of stream or whatever we're gonna do. I'm gonna see if I can just cheat. I'm gonna go talk to ChatGPT. And you provide pseudocode for, or you provide an algorithm for solving any 5x5 lights out puzzle in the optimal number of moves. Certainly, solving a 5x5 lights out puzzle optimally involves finding a sequence of moves that turns all lights off, assuming they're... You're typing too fast, man. I can't read this out loud. Stop. Oh my god. What has happened to us here? Oh, this is kind of right. Hold on. Assuming they were all Wait, turns all lights off, assuming they were all initially on. What? Yeah, 5x5 grid of Boolean values. True for lights on, false for lights off. The goal is to get the entire grid off, aka false. A move consists of pressing any of the 25 buttons, including those edges and corners of the grid. Breadth first search, BFS approach. Use breadth first to explore the state space of the puzzle. It's suitable here because it finds the shortest path of the solution in an unweighted graph, or state space in this case. State representation. Each state of the puzzle can be represented as a configuration of the 5x5 grid. Yeah, no problem. Start with breadth first. Assuming all lights are initially on. This is assuming that all lights are initially on. I don't like that. Visited states. Maintain a set of visited states to avoid processing the same configuration multiple times to prevent cycles. Yeah, so you don't get caught in an infinite loop. That makes sense. I think I confused the chatbot, chat. It's not very promising right now. Check if the current state is the goal state. What a novel idea. If yes, the sequence of all moves stored within the state is the optimal solution. That's not right. What? If not, generate all possible next states by pressing each of the 25 buttons. For each next state generated, if it hasn't been visited before, mark it as visited, and then queue it along. Okay, that actually sounds really like a good idea. Termination. If the queue is exhausted, without finding a solution implies the puzzle is unsolvable. Although all 5x5 lights out puzzles are solvable. Output. Once the goal state is found, the sequence of moves stored within its optimal solution to the puzzle. Implementation notes. Ensure efficient state representation in comparison to optimally memory usage and speed. Use a queue data structure for the BFS and a set for the visited states to ensure efficient operations. Track the sequence of moves alongside the state to reconstruct the solution path once the goal state is reached. Okay. This kind of makes sense. Emphasis on kind of. Also, good song, but it goes on way too long and just like ramps up getting more and more loud. So I'm gonna skip to the next one. Let's create a new project within this one. We'll make a class library. Hello? There we go. This will be lights out dot domain. I don't know. Also, I should have called this lights out dot solver, not solver. Oh well, too late. So sad. So we have a couple things we need to do here. We will call this lights out application. I don't know. Whatever. And then it will take a grid, not a grid, sorry, a dictionary? Probably. Yeah. A dictionary of dictionaries of Boolean, no. Int. No, wait. A dictionary of int to dictionary of int booleans. So that'll be the initial grid. Initial state, whatever. And we will store that. In a private variable. I guess to be fair, I don't know what we return here. We need to return something here. It'll be a sequence of moves. We'll just say a list of tuples of int. So that will just be like sequence of like coordinates for which buttons to press in order. And what we need to do is have like we need to have like a list of these dictionaries of visited states. Start with the initial state, because that's one that we've already seen. So we want to find... We need to loop through like every move of each state. And we also need to track like, did this move lead, like, did the sequence of moves lead to a dead end or not? So we need like a recursive function that we can call from here. This will be like you know what, actually? This is so much more easy to store as like a bool, double array bool. I don't know why I'm doing it this way. This will need to be there we go. So we need to go, like... We need to keep a running list of, like... of, like, the current moves that we have while we do this. And then, like, if the state after this move reaches us to a point where it's like a win state, then we add this to our list of like successes or whatever. Not read-only. Actually, this shouldn't be read-only either. Well, I guess it should be, because we don't want to reset the list, but whatever. Win paths, we'll call it win paths. So first we'll check if it's a win state, and it doesn't like that already. Oh. Oh yeah, this would need to be a list of lists, not a list of. So we have multiple paths that win, I guess. Then we need a... Thank you. This should also be private, I suppose. Keep this here. Whatever, man. There we go. Actually, hell, we'll do it this way. Whoa. Okay, so is win state is just like for int I equals 0, yeah. Oh, I plus plus. For int j equals 0, yep. Didn't quite do that right on the punctuation there, but otherwise great. If state at ij return false, otherwise return true. Okay, cool. And then we would just do... So this will actually work for, like, X by X puzzles, which is kind of cool. Or... Nope. God damn it. I just want this again. Oh, also we want to know if visited states... already visited state visited states, or well, yeah, that's fine. Just do an OR here. We'll implement that in a second here. check next moves. Make move ij state. No, wait, shit. I need like a new list. I need to copy that list. Ah, fuck. Okay, hold on. Yes, copy to. Wait. Fuck. Not a one-dimensional array. No, I want to duplicate. I guess I could copy to an array and then to list that array. Yeah. C#, copy, list. So I clone a generic list in C#. Oh, well, that sucks. Does that work? No, it does not work at all. Shit. Do your water shaders offset vertices in the mesh? Are they using ray marching? No, they offset the vertices. It's literally this tutorial. One second, hold on. This one, and then there's like a follow-up one that's right after it. That's all. That's literally all I did. It's nothing fancy. Current moves. I just want to clone this list. What is this mad about? Oh, I don't need the to list anymore. Oh, true, I could do that, I guess. And then new move list dot add new tuple. Thank you, autocomplete. Why are you mad about that? You know what? How about I just add IJ? How about I just add new IJ? What the fuck? What is this thing's problem? There we go. Got it. Okay. There we go. Now I need to implement both this. Shoot. Just gonna try making a water shader, but see how far I can go with that tutorial. Why not use the tutorial, then revisit afterwards. Just saying. Okay, so we need a list of visited states. Oh, I already have that. Am I adding to it, though? I'm not adding to it. I suppose after... Oh, shit. Yeah, after wind state, but before max depth, we should do this. But then we also need to check this separately. More of an exercise, honestly. You do you. Alright, so that's separate now. That's fine. Yeah, that's good. And we just need to compare... Oh, God. Oof. This is gonna be, like, not efficient at all, but I think, like, this is gonna be pretty, like... It probably won't matter, I guess. Wait, shit. Okay, no, it did I++ and J++, hopefully in both places? Okay, yeah. Freaked me out because it, like, did ++I, and I'm like, that's not what I want, I think? Maybe that works, whatever. It's so fucking crazy. No, wait, yeah, that's right. Okay, so if it's not equal, then we return false. But if we don't find any mismatches among all of the visited states for every cell of the state, then return true. Sweet. Very efficient. I mean, I guess reminder that this is like a 5x5 grid. So it's not that crazy, I guess. Okay, is win state should be above the other one. Just being neurotic about my coding now. Okay, so what we want to do is return a new state. Oh. When we do make move, int x, int y, boolean, current state. So what we want to know is if x is, well, x is less than or equals 0. No. X is greater than 0. Then we're going to do x minus 1 as well. Oh, actually, now I need to clone an array. A two-dimensional array. Is that not okay? What's wrong with that? Huh? If I put just a number here, is that also not okay? Oh, I see. Why is that not okay? What the fuck, man? Oh, right, I didn't... There we go. Alright. There we go. That ought to clone it quite well. No, it doesn't though. Fuck. Okay. So that just initialized it, doesn't actually set the value. So if we just make this a... Then we do another loop after that. Thank you for totally knowing what I was trying to type. There we go. That'll clone it properly. So if x is greater than 0... Well, okay, next state at x, y is going to be whatever the inverse of current state xy is. If x is greater than 0, then next state x minus 1, the fuck? Y is equal to not current state at not x minus 1y. And if y is greater than 0, then we also do that to x minus 1, y minus 1. You are making some interesting spacing choices, Visual Studio. You know what? Let's cram this together. Fuck this spacing bullshit. Or whatever, I guess. Fine. Fine, man. I'm not gonna fight it. Oh yeah, shit. I didn't change my title at all. Oh well, at this point, whatever. We're not gonna go on too much longer with this, in fact. I don't think we're finishing this, but I will finish this offline. Rest assured. Probably not gonna upload this part of the VOD, because it's just some random incomplete, incoherent, like, ramblings of myself. Okay. Then we also need to check if x is less than current state.length. Just copy all of this. So this is going plus... Wait, no. This is wrong. I don't need this. There's only like a plus symbol, right? So we go current square, then we go up 1, down 1, left 1, right 1. So we never do both at the same time. I don't need this. It's good. Just change this to a plus. That'll take care of the left and right. If y is... Nope. Oh yeah, that, actually. Oh, you were so close to being smart, game, or Visual Studio. Y is less than current state.length. We'll We'll do current state of x dot length. This probably won't work for a non-square puzzle anyway, but whatever, we're handling it, you know? Well, okay, doing the X will handle a rectangular puzzle, which, again, not part of what we're trying to solve here. We're trying to solve a 5x5 grid, so, like, that shouldn't matter, but whatever. And then we just return next state. Simple as that. And then we'll have up to 1, 2, 3, 4, 5 changes, but less than that if they're on corners. Perfection. Actually, we'll do this. Wind paths dot sorts. Take the shortest one, so we want counts, I guess. Yeah, that's ascending by default. Huh? Oh wait, sort's not a... Oh, wait. Nope, that's not right either. What do you want? God damn it. Oh, right, a comparer, yeah. Shit. So we want like 2. Oh. That's not right. What the fuck? C# link count, or not, sort. Oh, order by, not sort. Order by... first. There we go. Okay, I think this actually works. I think we actually did finish this. So now I need to, like, pass a thing into it. So program... How do I include that library? No, this exists. It's real, man. Add a reference, please. Thank you. Then yeah, it's invalid because I need to get the state, but let's take a random example, okay? Shall we? Whoa. Also, I don't know why it made my thing like this, but whatever, that's fine. I'm gonna just, okay, let's put it into test, like, actual real data, right? I'm gonna take the current puzzle I'm on and see if it gives me a valid answer to this. I'm gonna make a cleaner way to, like, put inputs into this application, but hopefully we can use this. Alright, that's a fucking mess. Okay, so I'm gonna write this out in my notepad over here. False. True, true. True, true, true. Also, it's a 6x6, not a 5x5. I'm an idiot. Alright, true, false, 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 true, false, false, oop. False, true, true, false, true, 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 false, 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 true, false, 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 true, false, 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 true, false, true. Thank goodness I made this generic to, like, any solution, right? You know? So that should be 6x6, right? 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. Yep. Yep, yep. Okay. So instead of 5x5, 6x6. State of 0, 0 is false. Actually, fuck it. I don't need to set the ones that aren't true. This will be false by default. Fuck, I need to do this for, like, every one of these. Zero index, so we're ignoring the first one because that one was false. I wrote it down on my notepad. I don't really need it up here on this screen over here. Whatever. So state of 0, 1 is going to be true as well. This row is a lot easier. And that will be 4, 1 is also true because that's 1. Yes, 5 is the end of it, so yeah. Next row is mildly more complicated. It's going to be 1, 2, 2, 2, 4, 2, and 5, 2. Then on row 3, we start at 0. That one is set to true. As is 1, 3, and then also 5, 3 will be true. Next row is just one of them. It's going to be number 4. 4, 4. And then the last row, there's 2 of them. No, it turned itself off. Is my battery dying? Might be dying. What timing? Or it has a sleep timer, I don't know, but that'd be quite convenient if so. Maybe it has an auto sleep timer, I don't know. Wait, I can look at the screen. Yeah, okay, the bottom corner, 5, 5 is also, yeah, 5, 5, so... Wait, no, not 4, 5, 5, 5. Oh, wait. Yeah, no. Wait. Yeah, 4, 4 for the second to last row. Then the last row, it would be 3, 5, and 5, 5. True. Okay. Bada bing, bada boom. And we do app.solve puzzle. Result. Console.writeLine. Optimal solution is... need to make a result string. so this will be... So result is going to be a list of tuple... Yeah, so we want string.join r/n result.select. Hope I didn't mix up my X and Y's at any point in this. Press pause to continue, I shall. Alright, let's run it and see what happens, chat. Did I do it? Ah! Value cannot be null. I never initialized win paths. God damn it. There we go. What? Oh, because it's read-only. Yep, fair enough. Alright. Son of a bitch. It's got none. It found nothing. Why did that run in like 1 second, though? Oh, shit. It already visited its own state. Yeah, okay, don't put that in there, because it's gonna, like... Ah! There we go. We're getting there. Still has no elements. What the fuck? Alright, let's walk through it. Is it a win state? It's not. Have we already visited it? Shouldn't have. The fuck? Oh, shit. I have this backwards. No, I don't. Ooh, okay, so I need to like implement this a little bit better. Let me turn this off for now. So this is not good because if the lit is empty, then it will misidentify this as it didn't, like, we visited the state already, which I think is also wrong for other reasons, so I can't just check is the list empty before going in here. No, we can. We can do that. If visited states... Oh, dot count is 0. Yeah, thank you. Alright, we'll let it run. Thank you. What the fuck is this output here? Alright, wonderful. Putting a breakpoint here now. Let's see what happened. Why am I printing hello world? What is this shit? Oh, it's not done. It's showing like a stack trace for some reason, which is weird. Maybe it errored. Maybe like a stack overflow or something. I guess fucking try catch it. What fucking build errors, man? Oh, yeah, I guess that's true. List of tuple. Int. Result. Result equals this. The row, the E, that's fine. Yeah. So I think it's stuck just looking for a solution here. What if I'm like running... Whoa. Windows sounds. Running out of memory running this application? No, it's not. It's not. It's not even close. Had to check just to be sure, but nope. Okay. Oh. Oh. Thanks. Thanks for that. Okay, well, we wrote ourselves a little algorithm. I guess, here, let's set max depth to, like, I don't know, 50? That's probably too many moves. Let's set it to 100. Fuck it. That should cause things to, blow up, I think. Not blow up, but, oh, there's an exception. What the fuck? What is the exception? Index out of bounds. Okay. Give me that stack trace. Juicy, juicy stack trace. Okay, so line 48 of the application. Interesting. Presumably somewhere inside of here. That's what was getting spit out in the console. It's just, oh yeah, line 91. If it's, oh fuck. No, yeah, no. If y is less than current state dot length. Ah, shit. Okay, we gotta do a -1 there on both of these. Or, I guess either way, right? Got one off, or got 0 indexed. No errors yet. It should call itself off at 100. Look at that process memory. 3 gigabytes. Oh my god, what is it doing? I created a monster. It is actually just eating up so much fucking RAM right now. Alright, shut it down, shut it down. Fuck that. It's using 6 gigs of RAM. Okay, so obviously not optimized by a lot. Even with the cap of 100 moves, or 100, like, depth of moves. Something's going awry here. Well, chat, I think that's what we're gonna call it. I don't know why this doesn't work. I'm sure there's a bug I did somewhere in here, but I will refine this, and then we'll be able to just hopefully just run it whenever I feel like, and we can go all the way through lights out on stream where you guys can see it rather than just on my stupid little handheld. We're close. We're very close. There's just that matter of using multiple gigs of memory to run this thing. It's a bit of a problem. But yeah, thanks for joining, everybody. I will be streaming tomorrow, but we'll be playing StarCraft 64. It's gonna be my last stream before I go on a big break. Having said that, I'm gonna try to coerce my house guests to stream with me a bit. Maybe there'll be no cam. I don't know. It's definitely not going to be anywhere near the normal stream schedule, but hopefully we can finish StarCraft 64 tomorrow, at least as far as the campaign is concerned. So yeah, until then, goon night, everybody. There's my OBS. Hope you like to see it, because it loves to just pop up on the screen for no reason. And I'll see y'all later. Peace.